All right, let's get right into it. We're going to tackle one of the deepest questions out there. What's the link between the completely bizarre rules of quantum mechanics and our own conscious experience? I know, it sounds like something straight out of science fiction, but as you're about to see, this is the absolute frontier where physics and neuroscience collide. This little poem, written about the one and only Erwin Schrödinger, just hits the nail on the head. It's all about psi, that's the wave function. And here's the wild part. For nearly 100 years, we've used it to make the most ridiculously accurate predictions in all of science, but we still argue about what it actually is. What does psi really mean? So what exactly is this wave function? Well, the best way to think about it is like a coin spinning in the air. See, while it's spinning, it's not heads or tails, right? It's kind of both. It's in what we call a superposition of all the possibilities. The wave function is just the math that describes that cloud of potential before anything actually settles down. And boom, right there, you have what's called the measurement problem. The math tells us the universe should be this huge, sprawling landscape of possibilities, all coexisting. But that's not what we see, is it? When we actually look, we only ever get one result. The electron is right here. The cat is definitely alive. So, why? Why does all that quantum potential just collapse into the single reality we experience? Seriously, this is the kind of puzzle that keeps physicists staring at the ceiling at 3 a.m. Well, back in the early 2000s, a physicist named Shan came along with this just wild idea, a truly radical answer. He basically asked, what if quantum mechanics and consciousness are just related? What if our own consciousness is the key that could unlock things we thought were totally impossible? I'm talking stuff like faster-than-light communication. Okay, so Gauss' theory gets pretty deep. He said, look, this collapse of the wave function, it's not just a trick in the math. It's a real physical thing that happens, and it happens everywhere, instantaneously. Now, you might be thinking, wait a minute, doesn't that break Einstein's laws? And yeah, it kind of does. So Gauss suggested there must be this preferred frame of reference for the whole universe, like a master clock for the cosmos that got set way back at the Big Bang. And the trigger for this whole process? He thought it might just be us, the conscious observer. But how would that even work? This is where it gets really clever. Gauss' whole idea hinged on this tiny little processing delay in our own consciousness. He theorized that it would take our brain a fraction of a second longer to perceive something that had to collapse from a bunch of possibilities versus perceiving something that was already a single solid reality. And and this is a big if you could somehow detect that tiny lag, you could tell the difference between quantum states just by looking. And if you can do that, well, you've just opened the door to sending messages faster than light. I mean, this quote from his paper just says it all, doesn't it? In his mind, the instantaneous collapse is like the railroad tracks for information to travel instantly across the universe. And consciousness? Well, consciousness is the only thing that can actually read the train schedule. It's a huge, absolutely mind-bending idea. But it's an idea that has some pretty big problems, not least that faster-than-light paradox. So that brings us right up to today, a brand new proposal from 2024 coming from a team that includes folks at Google Quantum AI. And they just completely flipped the whole question on its head. They said, forget about the end of the superposition. What about the beginning? Okay, so this is the absolute key takeaway. On one hand, you have the old idea that a moment of consciousness is the bang of the collapse. It's the instant a single reality gets picked. But this new idea, it's so much more elegant. It says a conscious moment isn't the collapse at all. It's the formation of the superposition. You see the difference? Experience isn't the final destination. It's the journey itself of existing along all those parallel paths at the same time. And this new way of looking at it is really powerful because, well, it just cleans everything up. You don't have to worry about defining exactly when a collapse is supposed to happen. It totally sidesteps any of those faster-than-light paradoxes. And it fits in really nicely with the whole many worlds idea in quantum physics. But the best part, the most brilliant part maybe, is that it gives us a potential solution to a really big mystery in neuroscience. And that puzzle is called the binding problem. Think about it. Right now, how does your brain take the light from your screen, the sound of my voice, maybe the feeling of the chair you're sitting on, and weave all of that into one seamless, unified experience of right now? It's a huge question, and this new theory proposes a really beautiful answer: quantum entanglement. The idea is that all those different parts of your brain get linked together, entangled, into one single indivisible quantum state. And that state, That is your unified experience. Okay, so this is all really cool theory, right? But can you actually test it? I mean, how on earth do you even start looking for quantum effects inside something as warm and wet and, well, messy as a human brain? This is where the story gets really, really good. Turns out the answer might be to just turn consciousness off. The logic here is actually super simple, but really powerful. If consciousness is made of these quantum superpositions forming, then anything that switches consciousness off, like a general anesthetic, has to be messing with those exact quantum processes. It just has to be. So back in 2018, a team of researchers did just that. They ran this incredibly clever experiment using xenon gas, the anesthetic. Now, the genius part was that they used different isotopes of xenon. Chemically, they're all identical, but some of them have this purely quantum property called nuclear spin. You can think of it like a tiny little magnet inside the atom, and others don't. And what they found was, well, it was stunning. The xenon atoms that had the nuclear spin were about 30% less effective as an anesthetic. A property that is 100% quantum was directly affecting consciousness. I mean, just stop and think about the implications there. This is huge. It's not just some random correlation. It's the first real hint that the actual machinery of our consciousness is sensitive to the quantum states of the atoms inside our brains. This one experiment gives us the very first real foothold. It takes this whole conversation out of the realm of pure philosophy and plants it firmly in the world of testable science. So what's next? Well, that 2024 paper lays out a plan to do these xenon experiments all over again, but this time with way more precision. They want to use lab-grown brain organoids, basically tiny little brains in a dish. And because you can cover these things with sensors, they can try to confirm the effect and maybe, just maybe, start to figure out exactly how and where these quantum effects are actually happening. And look, if this all pans out, if these theories get confirmed, the future could get really weird really fast. Think about it. If our brain is basically a type of quantum computer, could we build an interface with our quantum computers? Could we literally plug our minds into a machine at the most fundamental level of reality? This quote from the researchers really captures that long-term vision. The goal here isn't just to understand consciousness, it's to augment it. We're talking about building tech that could expand our awareness, letting us see and feel the world in ways we can't even imagine right now. And that leaves us with one last big provocative thought. Right now, we're all racing to build artificial general intelligence, and we're doing it on classical computers, right? Computers built on bits that are either a hard 0 or a hard 1. But what if our consciousness isn't classical at all? What if it truly depends on the fuzzy in-between world of quantum mechanics? If that's true, can a machine built on certainty ever truly be conscious? Can it ever truly experience a universe of possibilities? That is definitely something to think about.